Good morning, everyone, and welcome to today's webinar on techniques for efficient product design. So here, what we are going to do is we are going to design a brake pedal within the existing assembly. Then we are going to ensure the fit around all the existing components in the assembly, and then we are going to ensure that the component that we made has all the assembly relationships, and then we are going to test the existing pedal to make sure it has sufficient strength. So here we have a brake pedal assembly, and we'll see how we can create the pedal part inside the assembly itself using the create part in place option. So inside Solid Edge you have the option to create part in place directly, where you can place a coordinate system and decide if you want to edit the part right in the assembly. So once you make the selection for those options, the software will give you the option to place your origin, and then you can decide what standards do you want. So I'm going to use an isometric part file, but you also have options for sheet metal assembly and weldments. You have the option to ground the component, and this one is to make sure it is that you are going to edit the part in place. Once you hit accept, the software will ask you to save the part. So I'll just give it a name, pedal 5, and this puts you right into the part environment, as you can see. So even though I have selected as edit part in place, you'll see that my assembly is hidden, which will normally happen. So you can turn the assembly back on using the option that is called as hide previous in place, and the shortcut for that is Control plus Q. So here you'll see the assembly in shaded. Now what I can do is I can use this existing coordinate system and start my first sketch. So here I would like to make two concentric circles and give them the dimension. So the first one I'm going to give a dimension, let's say 21 mm, and the second one I'm going to give it a dimension as 17 mm. Now since we are doing this in synchronous, the user can quickly select the region itself and extrude it out. Now when you're extruding out, you don't have to specify the distance, because now since you're in the assembly environment, you can use the existing edges and endpoints as a reference to make the solid. So here you can see quite easily I have made my first solid. Something that I did not discuss is that you can also assign material for the part. So you can quickly go to the material table here and select the desired material. So here I plan to use steel as my pedal part. Next is where I'm going to attach a pivot here. So to do that, I would need a plane on which I need to make a sketch. So since we are in synchronous, we can simply select any face, and then using the steering wheel, I can decide exactly where I want to place that plane. So let's say I want to place this plane at a distance of 33 mm from the base reference plane for this part, and then I don't have to use this part, because now if I want to make a sketch here, you'll see that I'm not able to select anything right here. So for reference, I'm not able to select anything here, as you can see. But to to make a sketch, what I can do is we have a command that is called as project to sketch, and use the existing edges to make the sketch. So here I want to select this circle right here for reference, and this circle right here for reference. So this quickly creates these two circles as a start point, and using these sketches the user can very easily make the other sketches too. Now I can place a dimension here. Let's give this a dimension 20 mm, and to make that pivot I would like to place two tangent lines from this circle right here to this circle right here. Same I would like to do here as well. Place a tangent line from here to here. And now to make it a complete solid, I'll be using a trim command and trim off this extension so that the software identifies that as a solid region. And like I said, since you're in synchronous, you can quickly select the region and create a solid. So here I'm going to turn on my symmetric extend so that it extends on both the sides and give it a dimension, let's say 8. So here, as you can see, if you take a look from the left view, it is placed exactly at the center as it is supposed to be. And this is how you can make a solid or a part using the assembly itself. Now to create the rest of the part, I don't need the assembly. So to make my space less cluttered, I'll just go ahead and say show only to the part so that I can see, so that I can focus only on the part, right? So let me hide these dimensions. And now to make the actual pedal profile, I will need one more plane. Now that we have done some modeling in synchronous, we'll now move to ordered. And in ordered, we'll create a parallel plane. Now this parallel plane will be used as a start point to create the profile of the pedal. So to create a profile, I'll go to line command and select the plane which I just made right now, on which I'll be making the profile. So this profile is how or what is going to decide how your pedal is going to be. So let's make the first straight line, make an arc here, and then another straight line. So I want my pedal to look something like this, and using smart dimension, I can place all the dimensions here. So let's do 305 mm as the total length. Radius of this one is going to be 27, and this length is going to be 75. Now I also want to specify the angle between the inclined line and the straight line here, that is going to be 75 again. Now one thing that you might have noticed is that one of my sketch is black and one is blue, which means that the blue part is not fully constrained. And the reason why it's not fully constrained is because the line here does not have any relationship with the arc. So we need to place a tangent relationship between them. And once you do that, you'll see that the line here turns black, which means it is fully constrained. So once you finish creating the profile, we need to create the cross section for the pedal too. To do that, we'll have to place a plane that is normal to this curve of the pedal. To do that, I'll go back to plane creation and select a plane that is normal to the curve. And on this plane, we plan to make a circular profile. So to make that, I can go to circle and quickly create a circular profile. So here what I'm going to do is I'll place a dimension. Let's say the dimension here is going to be, or the diameter of the circle is going to be 18 mm. And now using the sweep command, I can sweep this cross section over this path. So we'll go to sweep command, select the path, and then the cross section. And it creates your pedal something like this. Now, now really good thing about ordered is that, or something new that has been added in ordered is that we have access to synchronous technology inside ordered. So some commands like move faces, offset faces, and rotate faces, we get access to synchronous environment, right? So we can quickly select the regions that we want to rotate. So here I want to rotate these regions, but accidentally I selected these faces too, so I can simply turn them off. And once I hit this green checkbox, you'll see that I get access to steering wheel even though I'm in ordered. So this is something new that has been introduced in the newer version of Solid Edge, so that the users can get access to both the environments at the same time. And using the steering wheel, I can change the angle here. So let's say I want to place the angle to 5 degrees here, so that the actual pedal can be depressed. And since we are making this change in order, it always creates a history here, as you can see. And if the user wants to change the angle again in the future, they can come here and change the angle, right? So once we have made that, we'll create a footrest for the pedal too, and that can be easily done using this extrude command. So here I'm going to create a rectangle by center first, and then place a dimension. Let's do 20 by 50 here. So we'll do 20 by 50, and very quickly we'll make a solid out of it. Since we are already in the extrude command, we can make a solid right here. So something like this, we have created our pedal. There's a small defect that the pedal cross section here is intersecting with the pivot. So what we can do is we can come back to the extrude command and quickly trim this out. So to do that, I'll select this constant plane and use the existing edge using the offset or sorry, using the project to sketch command and trim off that intersection. And that way, once I trim that off, you'll get like a really nice cut, as you can see here. So you see that within no time and quickly, I have created a pedal profile or a pedal part inside the main assembly. And if I go ahead and close this and turn on my actual assembly, should look something like this. Now this is not a complete assembly, so we are still going to need some additional parts to be connected here. So I'll go to my parts library and bring in the required parts. So here I'm going to add a pivot here which will go inside this pedal. So let me bring the part in, and very quickly inside solid edge I can place all the parts. So using flash fit, I'll just select this part right here, and it will axial align with this one. Flip the sides, we'll create one more axial align here, and then finally face mate these two faces. Now to attach this pivot bar, we'll need a M8 bolt. So we can bring that in from the Pathfinder itself, since that bolt has already been used here. So flash fit these two faces. This needs to be flipped, and then we'll create a face mate between this part of the bolt and this face of the pivot bar. So now everything looks good. Now let's try to simulate the motion of this pedal here. So to do that, we have this drag component command, using which we can just try to drag the component. So looks like not all the parts have been fully constrained. So we need to apply constraint. Even though we have designed the part itself in the assembly environment, we still need to constrain it. To constrain the part, we can use some commands like axial align this circular cutout with this circular cross section. Then we'll need to connect or axial align these two holes and create a face mate between we need to create a face mate between this face right here and this face right here. So now the part is fully constrained, and now if we try to move the pedal, it should simulate exactly the way we want. And as you can see, the part is following the profile or the way we have designed it to be moving. So this is how you can create your parts quickly inside the assembly itself, which will save you a lot of time going back and forth, taking the measurements and creating when you create the part inside a simple part environment. Now this is not the end. We still need to check for the structural integrity of the part that we have made. Now one thing you have to remember is that solid edge is not just a typical design tool. We also have add-on products like simulation. So a really good thing about solid edge simulation is that it is integrated right here inside the solid edge environment, which you can utilize inside the same environment so that you get the same look and feel inside solid edge. So to use that, I'm going to create, or I'm going to open this pedal part in a new window. And now I'll go to the simulation tab. Now let's start by creating a new study. We are doing a simple linear static study, and here I will be using a pin constraint for this circular motion or cylindrical motion, and applying a force on this pedal right here, and the force value, let's say, 1,000 Newton. Once you have specified the loads and the boundary condition, you can mesh and solve the model quickly from the mesh command itself. So once the model has been solved, you'll find out the high stress concentration areas, and then you can alter your model according to that. Now what has happened here is that you'll see that my high stress concentration areas is going to be right here. So my high stress concentration areas, the maximum stress, as you can see, is 569 megapascal, and my yield stress is 262 megapascal. So in order to reduce the stress, one thing that we can do is we can increase the diameter of this pedal profile, right? So to do that, since we are already in solid edge, you don't have to do a lot. Simply, just for the convenience sake, I'm going to hide all these loads, boundary conditions, and mesh that we have made. And using the sketch right here in the same environment, I can very easily make the change. So here, instead of 18, let's change that to 21. And once you close the sketch, the software will update your profile for the new cross section. Now, really good thing about this is you don't have to reapply loads and constraints. All you need to do is remesh the model. And just by hitting mesh and solve, the software is going to solve for the new cross section, and we should definitely see some reductions in the high stress concentrations. Now, as you can see, our stress concentrations now have been reduced to 346 megapascal, and previously it was 569 megapascal. So this is one way of very efficiently reducing the high stress concentration areas. Also, inside solid edge simulation, you can animate to see how the pedal is going to behave when actually depressed. So this is how a user can utilize Solid Edge to its full extent by not only designing inside Solid Edge, but also performing simulations, performing some other operations, like say for example, if you are someone who wants to do a motion study. So to do that, we also have inside tools, we have a dedicated motion analysis environment where we can actually simulate the motion of this entire assembly, and it looks something like this. So it is always a best practice to use all of these tools at once, so, and to its full extent, to get the best out of the software. So something else that I would like to cover is that you don't have to manually place the relationships for the part you just created. Solid Edge has a function that is called as the assembly assistant relationship, which will help you to place the relationships automatically. So let's take a look at that, how it works. So here is a command that is the assembly relationship assistant. And first, let's go ahead and remove the existing relationships first. So we'll just go ahead and say remove all these relationships. And now to place all these relationships back manually, you can use this assistant. Here it is asking to select from set to. So we'll just say one set. This is going to be my first set. And the second set is with respect to which other components you want to place a relationship. So here it is going to be this part here and the second part, and also I would like to add the pivot part here. So once I hit the green checkbox here, you'll see this window show up here. Make sure that we have this made selected, and once you hit process, the software creates all those relationships for you, and once you hit accept, those relationships are applied. So now if I go back to my pedal 5, you'll see that those relationships here are now applied. And if I were to similarly drag the component which I did previously, so if I were to go to drag and try to move the component, you'll see that it moves and behaves exactly like the way we tried before. So this is again going to help you to remove some manual work and automate the process of creating the relationships. So to summarize what we learned today in the webinar, number one, how we can use the existing geometry to make the components quicker to ensure the fit. Number two, how we can easily modify the existing features using synchronous technology and the new synchronous technology in ordered environment now. How we can utilize the inbuilt solid edge simulation to check for the structural integrity of the model. How we can take the advantage of the single integrated environment for greater flexibility to modify the model or do any other operations, and then how we can automatically capture the assembly relationships to eliminate a lot of tedious work. So with that, I would like to thank you all for attending the webinar today, and we are open to any questions that you might have.